When performing operations on radicals, it becomes too confusing to continue to use the plus and minus symbol. So out in front, when we're finding the square root of 16, we know that that is equal to a positive and a negative 4, because 4 times 4 is 16, and negative 4 times negative 4 is also 16. So therefore, we generally only use the positive root, which is known as the principal square root. And when multiplying and dividing radicals, we are going to just assume the principal square root. However, you will still follow the rules for multiplying integers. Therefore, you'll sometimes get negative answers. So, for example 1, simplifying perfect square factors with coefficient. Remember that the coefficients are the numbers out front, and we're going to simplify 20, the square root of 20, to the square root of 4 times the square root of 5, which is 2 root 5. And we're going to take that 2 and combine it with the coefficient 3 that's already there to get 6 root 5. Okay, on number 2, it looks like there's no coefficient, but remember that we can always put a 1 there. And so the coefficient on number 2 is actually negative 1. So let's simplify the square root of 28 to the square root of 4 times the square root of 7, which is 2 root 7. Oops. And we're going to take the 2 times the negative 1 to get a final answer of negative 2 root 7. Now we're going to get into some variables, so let's just take care of the 200 first. The square root of 100 times the square root of 2, which is 10 root 2. The 10 gets combined with the negative 5 coefficient that's already there, so we have negative 50 root 2. And then we have m to the 8th, so remember that that's 1, 2, 3, 4, 5, 6, 7, and 8. So pairs get to move out, so we have 4 m's that get to move out. So that actually becomes negative 50 m to the 4th root 2. See if you can try number 4 by yourself by pressing pause and then working it out and then pressing play to see how you did. The square root of 20 is the square root of 4 times the square root of 5, which is 2 root 5. 2 is the coefficient that I'm going to combine with 3x to get 6x root 5. Then we have x to the 9th, so that's going to be 9 x's. So there's going to be a leftover x inside the radical sign. So I know for sure it's going to be 5x. But 4 of them get to move out, and there's already 1 there. So it's actually going to be 6x to the 5th root 5x. There's several different ways that you can approach these problems. You can do the radical first, which is what I do, and then I combine that with the coefficient, and then I take care of the variables. But there are several different ways that you can approach the problem. None of the ways are wrong. It's just a matter of how you choose to approach the problems. Let's move on down to do some more problems here of simplifying radical expressions that have coefficients. Feel free to pause and then go to the very end of this to correct your answers. 5 root 2, and the 5 gets combined with the 3 to be 15 root 2. 48 is 16 and 3, which is 4 root 3. The 4 gets combined with the 2 to be 8 root 3. 24 is 4 and 6, 2 root 6. Negative 1 times 2 is negative 2 root 6. 72 is the square root of 32 times the square root of 2. Whoops. The square root of 36 times the square root of 2, which is 6 root 2. 6 times negative 3 is negative 18 root 2. Square root of 18 is 9 and 2, which is 3 root 2. The coefficient x there gets combined to be 3x root 2. For 300, the square root of 300 is 103, which is 10 root 3. 10 times negative 5x is negative 50x root 3. 12 is 4 and 3, which is 2 root 3. The 2 gets combined with the 3 to be 6. The 3 stays in the radical, and the x stays in the radical. For 54, we have the square root of 9 times the square root of 6, which is 3, root 6. 3 gets combined with negative 2x to be negative 6x, root 6. The x stays inside the radical sign for a final answer of negative 6x root 6x. For 27, we have the square root of 9 times the square root of 3. Again, if you get overwhelmed with these, just take it slow and break down each component separately and then put it all together. Square root of 9 times the square root of 3 is 3 root 3. The 3 gets combined with the coefficient 4 to make 12 root 3. Since there's two n's, the square root of n squared is equal to n, just like the square root of 25 is the square root of 5 times 5, which is 5. Okay, so the square root of n squared is n. That comes out here with the 12, so the final answer is 12n root 3. 28 is the square root of 4 times the square root of 7, which is 2 root 7. The 2 gets combined with a negative 6 to be negative 12 root 7. There's 11 n's, so 5 of those get to come out. So we have negative 12 n to the 5th, and since there's an odd number of n's, we're going to keep one in there with the 7. For 32, we have the square root of 16 times the square root of 2, which is 4 root 2. 4 times 11x squared is 44x squared root 2. X to the 7 means that 1 is going to stay in here with the 2, but 3 of them get to move out. There's already 2 there, so we're going to get 44x to the 5th, radical 2x. On letter D, we have 12, which is the square root of 4 times the square root of 3, which is 2 root 3. The 2 comes out with a negative 3 to be negative 6, x to the 3rd, y to the 5th, radical 3. We have an even number of x's, so 2 of them get to join the 3 already out here, so we have negative 6x to the 5th. We have 13 y's, so 6 of them get to join the 5 already out here, so that's y to the 11th, but one of them is going to be left over with the 3. So, whoops, I forgot the 3 in there. It should be 3y. So negative 6x to the 5th, y to the 11th, radical 5. Again, they get kind of crazy, but if you break it down into smaller steps, you'll be just fine as long as you show your work and you are understanding each of the individual steps.